In this video, we'll be going over majority element 2. So given integer array of size n, find all elements that appear more than n divided by 3 times. In our follow-up, we could solve the problem in linear time, which is O of n and O of 1 space. In our first example, we're given this array 3, 2, 3, and we can see that 3 appears 2 times, where this means the 3 appears 2 out of 3 times, which is greater than n divided by 3. So we output 3. Let's go with the dot process. Let's first recap majority elements 1. So in that question, we are trying to find all of the elements that appears more than n divided by 2 times. We can see that the majority elements can always cancel out all of the other elements. So, for example, if we have the current array x, y, x, y, x, we can see that the first x cancel out the first y, the second x cancel out the second y, and this leaves us with only x at the end. This means x is the majority elements, which basically means we can keep track of the frequency or the count of the majority elements. When we see an element that does not equal to majority elements, we can decrement the count. Then when we see an element that does equal to majority elements, we will increment the count. If count ever reaches to 0, we will update the majority elements. Now let's get back to this question. So in this current question, we are finding elements that appears more than n divided by 3 times. This means there can be at most 2 majority elements instead of 1. We can keep track of our 2 majority elements and also the frequency or the count of the 2 majority elements. Now let's go with the pseudocode. So we're going to create the following variables. We're going to have M1, the first majority element. It can be initially num0, the first element in the input array, and then also the second majority element, which can also be num0 in the beginning, and then we also have C1, the frequency of M1, and C2, the frequency of M2, and then we also have majorities, which is list to keep track of all majority elements, because we're outputting a list. Then we're going to iterate through the elements of nums, the input array, denoted as num. Now if num is equal to M1, we can increment C1. Else if num is equal to M2, we can increment C2. Now else if M1 is equal to 0, this means we can update the current majority elements. So I'm going to set M1 to the current elements, and then also set C1 to 1, because the frequency is equal to 1 currently. Now else if M2 is equal to 0, this means we can set M2 to the current elements, and then also set C2 to 1. Else this means the current elements is not equal to both of the majority elements. This means we need to decrement both C1 and C2. Now after we find the 2 majority elements, we need to verify that if they are actually majority elements or not. Because, for example, in this case, our majority elements is equal to 3 and 2, but 2 here is not necessarily appears more than n divided by 3 times. So we actually need to verify if our current two elements or two majority elements is actually the majority elements. Now, so if M1 is a majority element, we can just iterate through once and find the frequency of M1 and check with the size of the input array. Add M1 to the majorities. And then if M1 is not equal to M2 and M2 is a majority element, we're going to add M2 to majorities. Then we can return majorities. Now let's go over the time and space complexity. For the time complexity, we get O of n. Actually, it's going to be O of 3n. So we go to O of n, where n is the length of the input array. So we iterate through once to find M1 and M2, and then 2 iterations to verify the frequency, to verify if M1 and M2 are majority elements. Now for the space complexity, we get O of 1. Now let's go over the code. So we're going to create the following variables. The first majority elements, initially num0. The second majority elements, initially num0. The counts of the M1, initially 0. And count of M2, initially 0. And then we're going to create a list, majorities, to keep track of the results. We're going to iterate through the input array, the elements of the input array. If num is equal to C1 or M1, we're going to increment C1. Else if num is equal to M2, we can increment C2. Else if C1 is equal to 0, we can update M1. So M1 is equal to the current element and also update C1 to 1. Then else if C2 is equal to 0, we can update M2. Then we can update C2 to 1. Else, this means the current elements is not equal to both majority elements. So we need to decrement the frequency of both majority elements. After we find M1 and M2, we need to verify if M1 and M2 are actually majority elements that appear more than n divided by 3 times. So is majority M1, and inside nums, we can add majorities dot add M1. It's just a helper method. We're going to create this soon. Now, if M1 is not equal to M2 and M2 is also a majority, we can add M2 to our majority list. Then we can return majorities. Then we're going to create our helper method to check if the elements is majority or not. We're going to keep track of the frequency of the current majority element x. So n's count is equal to 0. Then we're going to iterate through the elements of the input array. If num is equal to x, we're going to increment count. Then we're going to return true if count is greater than nums.length divided by 3. Let me know if you have any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.